All right, so what do you think? Is that linear or not? Or, for that matter, is it just a blob? I'll go ahead and tell you my answer. It's too hard to tell. I think that's a pretty fair thing to say about this, right? It looks kind of blobbly right now. Now, we can try and get a better idea as to the relationship, right? Remember one thing I said at the very start of the semester. Never, ever, ever start anywhere on your axis other than 0. Always try and have everything start from 0. And that's what's on this graph, right? That's what's on this scatter plot. But it's really, we're really just wasting a lot of space on this graph. We're really wasting a lot of space on the scatter plot. So I'm gonna break my own rule. I'm gonna commit a bit of a crime here, but this is pretty much the only time it's okay because we are looking not for what the relationship specifically is, but rather is there even a relationship to begin with? And so this is pretty much the only time it's okay to stretch or really zoom in on a spot to see if there's a relationship or not. Not necessarily what that relationship is. And with it stretched out, you might, if you squint hard enough, see a vaguely upwards trend. Not great, right? Not a strong relationship, but maybe something. Or maybe you don't. Maybe you still think it's not. Truthfully, I'm still on the fence myself. I would have to get some more data here. Here's the scatter plot. I also got this from Triola Stats, where we had 62 households with an increasing amount of number of people in the household. And again, if you squint, you might justify a vaguely downwards trend here. But again, it's not super strong, right? It's not super obvious. So we still might be on the fence on this one too. And I can understand that. I can appreciate that. I would want to test to know for sure if these are correlated or not. And lastly, weather, temperature and time of day. This was recorded on November the 3rd of 2020. And you do see for a while, right, a strong linear relationship until sunset. And then it's a linear relationship again in the downwards direction. But overall, across the whole day, not so much, right? It goes up and then down. So there's not a strong linear relationship across the whole day. I would say that anyway. But again, who knows what the test will tell us? Of course, who even knows what the test is? But actually, one last point I would like to make, and then we'll start looking at that test. You can check for correlation for anything. You can even check for things that are normally distributed, right? I've got categorical data on my x-axis here, my horizontal axis. So we could do like months in the year, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So maybe we can relate month to ice cream and month to motorcycle theft. Maybe those two things are related. We'll check that and see that too. Because, right, like I just said, I can take the ice cream of each month and plot it against the motorcycle thefts per each month. And when you look at that, this is vaguely linear, right? As the number of ice cream cones get eaten in a month, more motorcycles get stolen. Who knew? So maybe that's correlated. We'll find out, right? We'll do the test. And this is the test, right? How do we do this test? It starts by drawing a line that best passes through your data set. And there is a coefficient that we'll be able to calculate that determines how good a approximation, how good a fit that line is, right? Some lines are terrible fits. Some lines are very strong fits. Obviously, when we're doing this, we pick the best line. But even then, sometimes even the best line is still terrible. But we'll use that line, and we're not going to do that part. We'll do that, though, to calculate the coefficient, right? Don't use that formula. Just don't. You can use the correlation there. You can also use Desmos to do it. But that will figure out correlation coefficients. So in the next video, we'll start talking about that correlation coefficient. We'll start talking about whether or not it passes the test, and we will go from there. So I will see you in that video.